Good morning, everyone. I am Swati Pandey, faculty in EX department, SIRT Bhopal. In my today's class, I am discussing the very important topic of basic electrical and electronics engineering, that is the superposition theorem. It is used in the DC circuit analysis. So let us start with this topic. This is the superposition theorem. Next, superposition theorem statement. If the statement of this theorem is very important, because when you will know the statement and the condition of this theorem, then you can apply this in any circuit. So let us start. You can see on the slide, in any linear containing multiple independent sources, the current or voltage of any point in the network may be calculated as the algebraic sum of individual contributions of each source acting alone. In simple words, you can understand this statement very easily, that in any linear active bilateral network you can apply the superposition theorem. So in any linear active bilateral circuit means linear means which follow the Ohm's law, active means where the active sources are applicable, and the bilateral means which circuit work from both the sides. But the condition is very simple, that here should be the more than one sources. If any one source is in any circuit, then this theorem cannot be applied. When the more than one sources in the circuit, then you can apply this theorem. So this is the statement of the superposition theorem. Next, the limitations is also here for this theorem when you will apply in the circuit. This is theorem, it does not apply to the power as the power proportional to the square of current. Understand that? Which is not the linear function. To find the power using superposition theorem, first you determine the voltage and current, and then you can calculate the power. You can understand this thing very simply by this line, that to find the power in using superposition theorem, firstly you will have to determine the voltage and the current, then you can calculate the power. Okay, so next slide. Procedure. How will you determine the voltage, current, or the power? As I told you previously, in the circuit where the more than one sources are there, then you can apply the superposition theorem. Suppose that you have the two voltage source, or we can say two current source, or we can say one voltage source or one current source. Anything may be possible in the circuit. So firstly, you will have to determine the contribution due to the each independent sources. It means आपको जो करना है वहां पर कि आपको पहले एक सोर्स के लिए आप निकालेंगे, आपकी मर्जी आप किसी भी सोर्स को पहले लें, तो आप वन टाइम में वन सोर्स को लेकर के आप उसका प्रोसीजर को फॉलो कर सकते हैं. सिलेक्ट ऑल अदर सोर्सेज टू जीरो. Voltage source will be short circuited and the current source will be open circuited. When you will take the one source in a circuit, then what will be the condition? If you are eliminating the voltage source, then this side where the voltage source are connected, this will be short circuited. Or we can say you are eliminating the current source, then this will be open circuited. So this is the procedure for eliminating the source and taking the one source from the circuit. The first condition is that you will have to take only one source and redraw the circuit. After redrawing, you calculate the voltage and current in the circuit. Second point is there, repeat for the each independent sources. जितने भी आपके पास sources हैं उसमें आप उन्हें one by one आप सारे sources का individual response, you will have to calculate the individual response for the circuit. Individual response means if you are calculating the voltage, then individual voltage you will have to find, and if you are calculating the current, then you will have to find individual current. In last, you will have to sum out all the responses that you get. Here is written also some individual contribution to obtain the desired voltage and current. Next, suppose that this is the circuit you have. This is the overall statement of the circuit as I told you. Again, I am repeating the one thing, statement and the procedure. You can apply the superposition theorem in any linear active or bilateral network where the having more than one source, then the total response will be is equal to the sum of individual response. This is the process. Okay, and how will you draw this. You can see in this numerical also, you are seeing the one circuit is here in the DC network, that here one is your voltage source and one is your current source. So if you want to apply the superposition theorem in this circuit, then firstly you will have to understand the procedure very clearly. This is your voltage source V1, है ना, and this is current source I1. It depends totally on your choice which you want to take firstly. Suppose I am taking the voltage source. Understand? Suppose I am taking the voltage source, then what is the condition? This is your V1 and this is your I1. ठीक है, आपने यहाँ पर V1 लिया और यहाँ पर आपने क्या लिया, I1 लिया. V1 I1 आपने ले लिया. अब आप क्या करेंगे, यहाँ पर आपकी मर्जी है, आप चाहे पहले V1 को ले लीजिए या फिर I1 को ले लीजिए. When you are taking the voltage source V1, now the current source will be open circuited because you are eliminating this. When you are eliminate this, then these 2 points will be open circuited. This is your point A and this is your point B, and this branch will be open circuited. Okay, so ये open हो गया आपका. And now this is your circuit. Okay, so according to your choice, if you know the Kirchhoff current law, or you can know the Kirchhoff voltage law, totally depend on choice, which you learn very easily, then you can apply this. Suppose I am applying here the node analysis, or we can say the Kirchhoff analysis, Kirchhoff current law, then you will write the name of node firstly here. So this is your node A, and after applying the node, you will have to write the equation. Then the equation will be VA minus 20 by 2 plus VA upon 8. Okay, and this is your open circuited branch. So you no need to calculate the things here because here the value of current will be 0. So this is the equation number first, and by this equation you calculate the value of VA and the current applied in these branches I1 and I2. Okay, so you will apply the voltage and current here and find out the values of these. Okay, so this all the things you have done by the source 1, by the source V1. In next case, you will have to take the case 2. In case 2, you will take the current source in the circuit and remove the voltage source. So the procedure of voltage source removing, this branch will be short circuited and the circuit is your this. Now you can apply again the Kirchhoff current law, or we can say the node analysis. Then the voltage value will be here, VB, node VB is there, and you can write simply the equation, and after writing the equation you will get the answers of VB and the second and another 2 currents from the circuit. Okay, after taking these individual responses, you get the final response of the circuit by adding the individual values of current and get the final current of the circuit. So this is the overall procedure of the superposition theorem, and in next cases you can do the practice for this. Suppose that this is your next numerical as you are seeing on the screen. You can apply this any circuit for solving the superposition theorem numerical. So thank you so much for listening carefully and understanding the procedure. Thank you very much.